Hello guys, welcome to Smart Insight. I hope you are ready to take great insights from this Smart Insight. And trust me, upon watching this entire video, you are going to feel the subject. So without any delay, let us see today's agenda. Today we are going to see a brief introduction to this machine learning. And let me start this discussion by raising a question: what is machine learning? So to make it simple and smart, I can say machine learning is nothing but making a machine learn. Well, but from where we are going to make a machine learn? And the answer is from the existing data. What it basically means is, if I have the data of a restaurant, I will simply feed the data to a machine so that the machine can understand the data and give us some useful insights like predictions, recommendations, and classifications. Since I am feeding the data of a restaurant, I can get the predictions like what will be the scope of my business in the future, and I can get the classifications like what type of customers are preferring to what type of food items. Okay, and I can get the recommendations like what type of items, food items, I can basically recommend to customers. And these are the things that I can get from the technique of machine learning. Since we are providing the intelligence to a machine artificially, it must be a subset of AI. Okay. By summarizing all these aspects, I can say that machine learning is a technique that enables a machine learn from the data and give us some useful insights like predictions, classifications, and recommendations. Well, but why machine learning? To make data-driven decisions, we need machine learning. Okay. You may think like, even we can also make data-driven decisions, then why should we go for machine learning? You see, sometimes even a pin drop sound can make our thoughts move from ourselves to South Africa, right? Then how can you think like we can do these many things, predictions, classifications, recommendations, that too when the data is very large? It is quite not possible, right? Then we should take the help of machine. Okay. Now we will see some examples of these predictions, classifications, and recommendations. Basically, predictions, the examples are market predictions. Market predictions means scope of the market in the future, and weather predictions and price predictions of a particular product. And coming to classifications, the best example is email spam filter. What actually email is doing is, it will collect the data from the both legitimate users and the spam users, and it will train the data to a machine so that machine can understand some patterns, and it will separate the mails into two groups. One is spam or not spam. That is basically classification. And another example is customer retention. And there are many examples. Just to say, I have mentioned these two. Coming to recommendations, we can recommend books, movies, music, courses by invoking the technique of machine learning. Okay. So from the beginning onwards, we have been shouting that machine learning is nothing but making a machine learn from the existing data. But in what way we can make a machine learn? So that is where the scope for discussing types of learning. Okay, there are various ways of learning. One is supervised learning, another one is unsupervised learning, another one is reinforcement learning, another one is semi-supervised learning. So before going to these technical terms, I will tell you an example so that you can understand in a better way. Here the task is, mother want to train her baby in identify whether the fruit is mango or banana. Okay, so the task is, mother want to make her baby to identify whether the fruit is banana or mango and place them in two different baskets. For example, basket 1 is for banana and basket 2 is for mango. Here, mother can do this thing in three ways. One way is, mother will pick a fruit and tell the name of the fruit to the baby so that the baby can understand this is banana and this is mango. And mother will repeat this step in n number of times until baby gets trained. Once baby gets trained, whenever baby see a new fruit, baby can identify whether the fruit is banana or mango and place them in respective baskets. Okay, hence the problem solved. And second way is, wait. The second way is, mother will basically provide some fruits in the basket and do nothing. Baby will pick a fruit based on the similarities. Baby will separate them into two clusters, cluster 1 and cluster 2. Their similarities include shape, color. Not only these, there are many things, right, that will differentiate a fruit from another fruit. Here, banana and mango. Based on these factors, baby can separate them into two clusters, hence the problem solved. And third way is, baby will pick a fruit randomly. Baby will randomly pick a fruit and then place it in a basket PO. and mother will see the task. If mother finds baby is doing in a correct way, mother will give a positive feedback, means you are correct. Otherwise, mother will give a negative feedback to the baby that you are wrong, that is not banana, that is mango, so that the baby can understand from the feedback given by the mother and place them in a correct way once she receives feedback. Okay, so remember these three cases. Now we will try to understand those steps. So in supervised learning, we have label data. Just like in our example, mother is providing the baby an information about the data, whether the fruit is mango or banana. Means mother is basically labeling the data. In the similar fashion, when we are feeding a data to a machine, we will provide labeling of the data. We will basically give the output of the data so that the machine gets trained. Okay, that is supervised learning. In unsupervised learning, there is no involvement of labeled data. Here we are using unlabeled data. In the example also, mother is not telling any prior information about the fruits, which is whether it was mango or banana. The baby finds the similarities and group them into various clusters. That is basically unsupervised learning. Reinforcement learning is something that improves with common feedback, just like our case 3. Okay? And the type of problems can be solved using supervised learning are regressions and classifications. Regressions are nothing but just like predictions, and classifications are nothing but just we have seen email spam example, right? And classifications are nothing but classify them into 2 or more groups based on the labeled data, and clustering, grouping them into clusters based on the unlabeled data. Okay, and reinforcement learning is something that improves with the human feedback. So these are the various types of learning, but how all these things will work. If you are new to this subject, you might be wondering, or it might be an hypothetical situation for you to understand all these things. But be in the present, I will let you know everything. So these are the some basic steps in any machine learning process. So the first step is we need to gather the data, and the next step we need to understand the data. Understanding the data in the sense we need to know everything about our data, and data pre-processing. Once we have understand the data, we need to pre-process our data. It means we need to clean our data. It involves checking for the null values, checking for the duplicated values, and if there are any outliers, we need to remove them. So basically, I can say data pre-processing is nothing but making data fine. Okay. And the next step is separation of independent and dependent features. It means, for example, if I have the data set which contains the columns like age, experience, and salary, you can see here, based on age and experience, we are going to predict the salary of an employee, right? So salary basically is a dependent variable, and age and experience are independent variables. We need to separate both these variables. Okay, dependent variable mainly on y-axis and independent variables on x-axis. So we need to separate x and y, and we need to split the data into training and testing. To split the data into training and testing, we need a function that is train test split. This thing we can get from the scikit-learn library, and I will show you in the practical implementation. Okay, and the next thing is model training. So training a model in the sense we need to invoke a machine learning algorithms based on our problem, and then we need to fit the data to this algorithm so that it will get trained. And evaluating in the sense we need to check our results whether it is giving correctly or not. And deployment in the sense, once we satisfied with our model performance, we need to deploy in a cloud platform so that everyone can access our model. Okay, now let us see an example. So to illustrate how things will work, here I have taken a small data set, and I will try to feed this data to this machine, and I can basically get some predictions. So the first step here is I need to import the data set. For that, let me import pandas first. Now, with the help of these pandas, we can read the data. With the help of this read CSV function, we can read the data. And we need to specify the dataset name here. In this case, my dataset name is dataset itself. Okay. You can see here, this is the dataset. It contains years of experience, age, salary, and the columns. So to make some operations on it, let me store it in an object. Now, to understand the data, let me do some operations. Let me try to execute this data.shape. Here, we can see 30,3 basically means our data set contains 30 columns and 3 columns. So let us see what are those 3 columns. For that, we need to execute data dot columns. You can see here, years experience, age, salary are the 3 columns that are present in this dataset. Okay. So let me check if there are any null values in my dataset. For that, I need to use isNull function here. Here we can see years of experience 0, age 0, salary 0. It basically means no column contains null values. Okay. Let me check if there are any duplicate values in my dataset. If there are any duplicated values, I have to remove them. Okay. For that, I need to use this function duplicated. You can see here 0. It basically means there are no duplicated values. So to get some statistical inference from the data, we need to use this describe function. You can see here mean, median, mean, standard deviation, minimum, maximum, 25th percentile, and count. All these things we can get by using describe function. These are the some functions which are used to understand our data. So the next step is we need to separate independent and dependent features separately, right? Let me print the data again so that you can understand. Our dataset contains experience, age, salary. Here, based on age and experience, we are going to predict the salary of an employee. So salary is dependent on these features, right? Then salary must be dependent variable and these features must be independent variables. We need to separate salary from these two. Okay, let us do that. Our X is independent variable and we need to mention the columns here, years experience, and another one is age. You can see here, if I print X, there are 2 columns, means salary got separated. Okay. Now do the same thing for Y also. Basically, the column name is salary. If I print Y, you can see this is the salary column. Now we have successfully separated dependent and independent features. And the next step is, now we are going to split the data into training and testing data. Okay. For suppose, if here we have 30 rows of data, right? If we consider entire data for the training, then after building our model, how can we know whether our model is executing or performing correctly or not? We must keep some data for testing, right? Then only we can see whether our model is working fine or not. So we need to split our data into training and testing data. Here we have 2 variables, X variable and Y variable. Y is dependent variable. X is independent variable. We need to split into X train, X test, and Y train and Y test. Okay, both the variables we need to split into X train and X test, Y train and Y test. So here we have got 4 sets, right? So let me do that. So before that, to do this, I need a function called train test split. That thing I can import from sklearn library. So from sklearn library, sklearn dot model selection, I will import train test split. Okay. Now I will split the data into testing and training data. Here I have 4 variables: X train, X test, Y train, and Y test. I need to make use of this train test split. Inside I need to provide some, what I can say, arguments like X comma Y. We need to separate these 2 variables only, right? That's why we need to provide that. And we need to provide test size also. Let me give test size as 0.2. 0.2 means 20% of data will be kept for testing data. Here we have 30 rows of data, right? So 20% of 30 means 6 rows we have kept for testing. So let me give random state also. I will let you know why should we give random state. Let me execute this. And let me print some Y test or Y train. We must get 6 rows, right? Because we have given 0.2 as the test size. If I have, you can see here, when I print Y test, you can get 27th row first, 15th row next, and then 23, and then 70. If I again execute, it will remain same. If I haven't provided the random state, if I execute it, and if I execute Y test also, you can see here, 3rd row first and 18th row next. If I execute it again, it will again split in different manner. If I keep on executing again and again, it will keep on varying. It means our model will train with different data upon each run. Okay, that should not be ideal case. So we need to provide random state here. You can provide any number as random state. For most of the cases, we use random state equal to 42 for the better accuracy. Okay. So we have successfully splitted our data into training and testing data. So the next step is we need to use an algorithm here to train the model. Okay. Here, based on our purpose only, we will select the algorithm. Here, we are going to predict the salary of an employee based on years of experience and age. It means it is a type of prediction problem. We have already discussed that in supervised learning, we have prediction type of problems and classification type of problems. In prediction type of problems, we can use algorithms like linear regression. Regression type of algorithms, we can use multiple linear regression and so on. Coming to classifications, we can use algorithms like support vector machines, decision trees, and logistic regression, and so on. Okay, since here the problem is a kind of prediction, we will use linear regression. Okay, so let me import linear regression first from sklearn dot linear model. Import linear regression. Okay, L should be capital. Here we have imported the linear regression successfully. Let us invoke that linear regression into our model. So let me create a variable like model and invoke linear regression. Okay. Now it's time to train our model. Training in the sense we need to feed the data to this model so that the model can understand the data. Okay. For that, I need to use this fit function. With what data we should train? Train data, right? We have X train and Y train. You can see here our linear regression model has successfully trained. Now we can start our predictions. Here, what should we give? Years of experience and age. Let me give experience as 2 and age as 34, and let us see how our model is, how much salary our model is giving. You can see here 76,447 is the salary that our model is predicting. So I hope you like this, and now you can get some idea how machine learning models will work and how they will train by the data and how they will give results to us. And if you want to check whether our model is working properly or not, we have some metrics based on the algorithms. Since we are using the linear regression here, we have root mean square error is a metric. Basically, if the value of RMS is very low, it means our model is working fine. Otherwise, we need to improve our model. But here, we are there to understand how a machine can learn from the data, right? So, we will compare the data. Yeah, let me execute model.predict. Let me pass. We have kept some data for testing, right? Let me pass xtest in the predict function. What should I get? Y predictions, right? So let me print those Y predictions here. You can see here, these are the Y predictions, means these are the values predicted by my model. Okay. Let me print the original values. I have kept for testing, right? You can see here, this is the original value and our model is predicting this value. For 112635, our model is predicting 118686. For 67938, our model is predicting 67497. Even though these values are exactly not same, but our model is predicting nearly right. So in this way, a machine can learn from the data and give us some useful insights. I hope you like this video and I hope you can feel what exactly machine learning is. If you like it, please subscribe.